Hello, everyone. Good morning, good afternoon, and good evening from near and far, and welcome back for this week's Data Center Deep Dive session. We've got a solid panel put together for you all today, focusing on data center development for the new age of facilities, delving into how edge data center solutions are evolving to meet tomorrow's end user requirements. I'd like to give a big shout out and thank you to all of our distinguished speakers, our attendees viewing at home, our lead sponsor, and of course, my team here at BizNow. Today's lead sponsor is PTS Data Center Solutions, led by Pete Sacco. Please also note the following housekeeping details for today's webinar. First, to all of our attendees, if you are not presenting today, you are both on mute and without video, so no need to be dressed up for the occasion. There will be plenty of time for questions along with the session. Click the box that says Q&A. We'll try to get to as many of your questions as possible, but please note that only questions asked in the Q&A section will be answered because we'll likely miss them if you're asked in the chat section. Please also say hey in the chat section and let everyone know who you are, where you are, and what you're working on. Additionally, throughout the webinar, we'll be sending out polls, giving you the chance to share your opinions and help drive the conversation forward. And finally, don't worry about taking notes. This webinar will be recorded and sent to you after we conclude, so relax and enjoy the conversation. Now, today's session will feature a wealth of industry knowledge. Our speakers include Rajesh Gopinath, product leader from Bloom Energy, Marisa Jules, Director of Architecture and Infrastructure from Georgia Institute of Technology, Phillip Marangella, CMO from EdgeConneX, and will be moderated by Pete Sacco, founder and president of PTS Data Center Solutions. Now let's get started. Take it away, Pete. Oh, you're on mute.
It's the mantra for the ages, isn't it? So thanks, Adam. I appreciate the introduction. Like I said, my name is Pete Sacco, founder and president of PTS. And so we've got a great panel today, and we'd like to talk about Edge. And so let's jump right into it. And so we're living in a world today where the edge has become an ever-present thing. And amongst my clients, what I'm recognizing right now is an evolution of what that means. And I'm seeing a threefold attack of the edge. We're seeing an on-premise edge requirement tied to a regional data center play, often, sometimes co-location, sometimes an on-premise solution or on-site solution, and then cloud. And that cloud play that we're seeing is I'm seeing a common theme of cloud first, but not cloud only. So the first thing I'd like to ask the panel is, in this world of the evolving cloud hybrid strategy, what is the perspective that you're seeing? And how about we start with Marisa? What do you think in that cloud first? You know, how does has Georgia Institute adopted this hybrid strategy?
So we're probably a little bit different than some organizations. We're not we were cloud first for a very short period of time and realized that didn't make sense. And so we've shifted to a cloud where it makes sense strategy. We have a so we have a top 500 supercomputer on site. It's in our primary data center. And so we effectively have a large data center. I mean, I don't want to say we're stuck with it, but I mean, it's something that we are going to have for the foreseeable future to maintain the plant for the supercomputer. So adding on to that in terms of enterprise computing for us is a relatively low cost thing. We have a sunk cost in our data center. And so we look at cloud as a way to take advantage of microservices and additional functionality that's available in the cloud, and not necessarily as the primary solution for many of our internal customers. And so that's how we're choosing to navigate this. We'll place an application in the cloud when it makes sense to do so, when there's some value driver for that. Otherwise, it lives on-prem in our existing enterprise data centers today.
You know, it's funny, I always use that line of cloud first, just not cloud only, but I love when you describe it as cloud appropriate, because, you know, that is a great way to describe it. As a data center designer for the last 20 years and watching the evolution of that, you know, I feel like we have the dirty little secret that I understand that an on-premise data center, much to the surprise of everybody, is the lowest cost option. I have found it to be the lowest cost way to actually, from a return on equity standpoint, and that's not the conventional logical feeling. Phillip, how about we spin to you as a guy who's been building purpose-built edge data centers for, like me, long before it was called the edge, right? And so what is your perspective on the hybrid economy that we find ourselves now?
Yeah, hey, thanks Pete for the question, and thanks to Adam and BizNow for having me take part in the panel today. Look, because as you said, we've been building out the edge for the last 10 years, long before like this even became, interesting topics for panel discussions, way before it was cool. And look, at the end of the day, our vision was, bringing content originally closer to the edge, closer to the eyeballs, right? And there was cost factors, there's performance factors that really kind of drove, much like, CDNs did. The edge data center was kind of this brick and mortar CDN, if you will. And that was kind of the first wave for us. The second wave, obviously, is cloud and bringing the cloud closer to the end users, right? And that's what's been a big driver for us. And people ask us, how do you define the edge? And it's not necessarily a tier 2 or a tier 3 market. It's not necessarily something that's sub 2 megawatts. It's defined by the customer. And for the cloud guys, it spans the spectrum because they have cloud on-ramps and cloud nodes and very network type of deployments, everything to, huge server farms. And we've been able to support the cloud's edge in that regard and building out that kind of whole spectrum of different types of data centers. And, again, performance, cost, security, and so forth. But ultimately, it's also about customer experience and bringing it as close and have that flexibility for customers like Marisa or financial institutions or other large enterprises that want to optimize their existing on-prem facility, want the flexibility to get, multi and hybrid cloud kind of as near prem as possible, and enabling this kind of ecosystem to kind of come together, right? It's not either or anymore. It's that whole continuum of size, that flexibility on location, and that diversity of choice in terms of the types of cloud, depending on the deployment that you might want to leverage in that respect.
It's funny, in the age of cloud, I think the original thought was we were simplifying everything, but quite the opposite happened on the way to the show, right? We actually made a supremely more complex approach to how we own and operate data centers by giving us options, and options is flexibility, and that's good. We have found at PTS probably 4 main factors when people are deciding what their data strategy or workload strategy is. We find that they're using on-site edge when there is some level of local autonomy or limited autonomy. So if the world disappeared, whatever's going on in that facility has to continue to trudge on, whether it's a drug manufacturer who's distributing and manufacturing drugs, whether it's a university who's on learning has to continue. We find that limited autonomy is one. We're finding bandwidth and latency, like you mentioned, Philip, is a key play to there. And then the fourth is a big mishmash of governance, compliance, and security and things like that. But in staying with that topic of keeping that infrastructure on site on that edge, what trends in those edge facilities are driving kind of the density demand? And are you using a modular approach in your data center? I know yours are largely driven by what the end user wants, but your business, a bit like mine, we're often having to make that suggestion as to, well, what is the best way to design it today? So what trends are you seeing in facilities design as it respects to modularity and power? And I promise, Rajesh, this is where we're going to bring you in, right? Because I know everybody here's got some Bloom Energy, thoughts about that. So Philip, why don't you talk to us about some trends going on in the...
Well, just, in terms of the drivers of the edge, right? Like, I mean, I think the pandemic, obviously you saw a burst in terms of demand. I mean, we as data center operators are all building at maximum capacity to support a lot of the demand. I think what happened was plans for digital transformation and migration to the cloud were just accelerated. They were already in place, but as people had to work from home and what have you, people started reevaluating and shifting from capex to opex and all this stuff. So everything got accelerated. It doesn't mean there's going to be a shift back, because now we're accustomed to this kind of new normal, if you will. And at the end of the day, because we're working from home and studying from home and gaming from home and shopping and all this kind of stuff, you're seeing this broader trend of less about the data center. It's more about the flow of data, right? And the impact of networks. We can't forget the impact of networks. And this is where the edge comes into play in terms of the peering capability to route that traffic, because you have the increase in volume of traffic, increase in variety, as I talked to you about, and then obviously the increase in velocity that necessitates a much more distributed architecture, right? And so, that's what you're seeing, a big growth of, not only because of the pandemic, but then you have new things like IoT, right? Telemedicine, machine learning and AI. This is all putting a burden on network traffic. And I often say we have to re-architect the internet, if you will, because it's been traditionally download centric, unidirectional, and now it's bidirectional, right? We're creating so much data at the edge, it either stays locally, it goes to other edges, we're back to the core, and it's this flow of traffic that these edge data centers are going to help alleviate and smartly route the traffic flows. That said, as these edge data centers propagate, one of the long, and I'm trying to set you up here, Rajesh, is the long pole in the tent centers around power. That's the next thing, of being able to power these facilities and being able to scale up as the capacity scales up with, the line of sight for power. And the bigger issue, even more so, is internationally, is having, it's less about building a data center and getting network. That can be achieved. It's getting power in a lot of these markets and locations internationally you might be able to solve for today, but having enough for future demand in a consistent and scalable manner is the key challenge for many data center operators like ourselves.
Yeah,
Thanks
for sure. And that's exactly why, Rajesh, and we'll go there now, because that's how you and I are partners, right? Because as a data center operator, we started working together because clients were asking, how do I get a more resilient power to the edge, and how do I get it, cost controlled? And so we evolved, and we've talked about it all over the place about my data center facility reimagined approach, where we're kind of turning it up on its ear and saying, look, the primary power energy source is going to be a bloom, and we're going to power not just the critical load, but the essential load, and we're going to run everything through it. And then I combine it with obviously an IDEC cooling solution in order to get PUEs of sub 1.1. But just very quickly, Rajesh, we're going to talk more deeply about the technology, but what is some of the things that you're seeing in usage of data centers as it relates to Bloom Energy?
Yeah, thanks for that setup, Pete and Philip. Thanks to Bizna for hosting us as well, guys. Bloom is in the business of, we're manufacturers of solid oxide fuel cell technology. We are the world's leading manufacturer of fuel cells. What we've been hearing from our customers is that for the edge, what we're looking for is a power solution that is eminently deployable, that's modular, scales with the scale of the operation that they want to build on. And they want cost predictability of their energy costs. As you know, energy is one of the largest component of the operating expenses of a data center, accounting for more than 40%. So getting a handle on energy costs is very important. While having said that, it is also important that we source our energy from the most sustainable sources, and we do it in a manner that aligns with the business goals for the organization and for our clients as well, right? So, annual surveys from the Uptime Institute, for example, has also talked about the power outages being the #1 cause of data center disruptions, and accounting for more than a third of data center outages. So reliability is extremely important, whether it be at the edge, whether it is in the enterprise, whether it's in a co-location facility or a hyperscale. And that's where we see the beauty of the Bloom solution is to deliver a very cost-effective, extremely resilient, and sustainable solution for data centers, be it in the edge, in a smaller scale, or in the hyperscale where we need a large amount of power concentrated in one place.
Yeah, that's great. We want to talk more deeply about that, but I want to swing to Marisa and talk about and stay with that idea of Are you seeing your facility on-prem, since you've been operating in Edge for a long time now, are you seeing density grow? Are you seeing your facility expand? Are you seeing data usage grow on your site? Are you leveraging modular approach to the data center expansion and design? What are some of the trends going on at GIT?
Absolutely. So I'm happy to talk to that. I think that's a great question. But to go back, just to talk briefly about the the fuel cell, right? So, and we may get to this later, but we have an urban cogeneration site associated with our data center, and the fuel cell is part of that. And one of the reasons it exists, going back to this, this idea of power is one of the largest costs of operating a data center, electricity. Georgia Power built this facility primarily as a research platform, right, to see what you can do in urban cogeneration. And one of the primary use cases is peak shaving, right? So in the hottest days of the year here in Atlanta, it's hot, demand is sky high. They bring power plants online that cost 2-3 times what the average is, right, to generate power. The Savannah River plant is the one that I think of, because when you go to Savannah, it's right across the river and it's always quiet. You wonder, why does this exist, right? And so the ability to limit utilization, right, to shave those peaks off and save that massive cost on their side, I think is also a benefit on the generation and delivery side, right? And so there's some value there that they're exploring, and it's an interesting field. But going back to the modularity and the change, we designed and built this facility in conjunction with our operator to be very modular. We require a lot of flexibility. We don't know what's coming. And so we wanted to make sure that we could adapt this facility to fit whatever was coming in the next 10 to 20 years, because we really don't know what it's going to look like. Our initial density target for our research data hall was 45 kilowatts a rack, and we're in production at 43 with most of those racks. But the cooling infrastructure was designed to handle a capacity of up to 100 kilowatts a rack, because we simply don't know what's coming. We have water to the device, water to the chip in a few locations. In that data center, we have rear door heat exchangers, so we can evacuate that heat directly, which gives us a lot of flexibility and modularity within the data center. We can have a 100 kilowatt rack sitting next to a 5 kilowatt relay rack with a couple of switches, right? And that's something that we thought about up front, because of the challenges we've had in supporting these novel new technologies for our research customers. The other thing we've discovered is that one of the drivers, up before the pandemic, right, one of the big drivers of this facility and some of our design was that people wanted to be close to their data. When you're working with very large data sets, you almost have to be nearby the data. So this is a multi-use facility where we have an urban data center next to an office tower that's got space for our state institution, plus it's an independently owned facility, and so commercial customers can lease. And there's direct fiber connects across into the data center. So you can have your data right there, right? No low latency effectively. And so that was very attractive. What we're finding now, people aren't moving into the offices right at the moment, because nobody's in an office anywhere. But what we found is that data still has gravity. And so it's almost turned into a situation where it's cloud-like. We have a researcher that has a multi-petabyte data set that's growing at the rate of about 0.5 petabyte a year or more. And so it's about 100 terabytes a month. So it's more than a petabyte a year, right? And this data set is so big, the customers have to come to the data, and to house it in the cloud would be cost prohibitive. There's some regulatory requirements around this data. It can't just be running around, so we have to protect it. And so we've thought in terms of how that data set grows and how we provide access for that, and can add both mechanical capacity and electrical capacity to the facility, but also modularly add what our customers may want to bring to access that data set. Right. And so that's been a huge concern of ours as we've gone through this build and deployment process with this facility. So our edge is really not only our customers, right, on campus, but it's also the users of this data that are coming and co-locating right next to it to have access to it.
Yeah, that's perfect, because I think that's just manifests the trend that I'm seeing, and where Bloom is going to play. I mean, it's the oldest technology that nobody knows about yet. That's how I kind of see it right now, because where we're seeing it right now is that anybody who's operating on-prem either people or IoT or technology or data sets in the form of a data center. If you have something going on 7x24, we're going to see the proliferation of using that alternate energy source, what Bloom does well, provide me super resilient power at a predictable cost with, with high sustainability, no emissions to the economy. And so I have all of the things that set up good for data center operations. So if you have a campus, that's the people that should be looking at this. And then if you have that resilient, reasonably priced, sustainable power, well, then your edge operations that was one of the reasons why you moved your workloads offsite, was because you couldn't have that resilient, sustainable power. And so now we're seeing, not only do we need autonomy and performance at the edge, but now we have a power architecture that we can actually deliver, that power to, that power to the edge. Rajesh, can you talk about some of who are some, I know in these forums, I can't often talk about who the customers are, but what types of facilities are you seeing beyond the data center right now that are building out these resilient power, be it microgrids or just a pure fuel cell? What are the types of applications that you're seeing that are building out now?
Yeah, so Bloom has till date more than 500 megawatts of fuel cells deployed around the world that account for almost 600 individual sites, 600 individual customer sites that are in operation over the years. And among them is about 70 megawatts of data centers. And we're talking about enterprises, large technology companies, but also co-location. Co-location is a big customer of ours. So there are data centers of various types. Outside of the data center space, we have hospitals. Kaiser Permanente is one of our largest customers.
Yep.
And in manufacturing, a lot of pharma, biotech, chemicals, food and beverages, and the like. We have retail stores. So and of course, university campuses, right? The one that Marisa just talked about, which is Georgia Tech facility, which is supporting a data center, the HPC facility that she talked about. We're proud to be part of that. That is a project that we worked on with Georgia Power and DataBank. Obviously, there are others as well, UCSD, San Diego, Caltech, San Francisco State, Keio University in Japan. So there's a number of universities as well that have taken advantage of the ability of the fuel cells to be the underpinning asset on a microgrid. So one of the things that we have to kind of appreciate here is that data centers in a university environment is actually one of the largest consumer of electricity, but it has to fit in, right? The data center power supply and environment has to fit in with the broader context because of the outsized impact that a data center has on its surroundings. And clearly we want to be making sure that we source the power responsibly, sustainably, and the cheapest power we can get as well.
Yeah, very good. Phillip, from your perspective, are you guys using microgrids, and dare I say a Bloom Energy or lithium-ion batteries, or you're using, what are you using at your power resiliency at the edge? What are the customers demanding these days?
Yeah, so a couple points. I thought what Marisa had to say was really interesting, right? And is a great anecdote and representation of why the edge is growing, right? Because for Georgia Tech to use the cloud, they're not going to go to the cloud in Iowa or Eastern. It's just that those economics don't work when you factor in the network aspect, and that's why we are seeing more and more customers, wanting the cloud come to them because of that data gravity that Marisa talked about. From a power perspective, look, I'm the chief marketing officer. I'm not the best guy to talk about that. What I will say though, right, is for our customers, and this ties into Bloom Energy, it's about sustainability, right? And it's about, they have aggressive goals to be carbon neutral or carbon negative even by 2030 or 2040 or what have you. And we ourselves, having recently been acquired by a Swedish infrastructure fund, obviously we have our own aggressive goals to be carbon neutral as well, right? At the edge, we achieve that through renewable energy credits based on wind and so forth. And but sustainability is a huge factor in how we go about it. It's not just it's a broad in scope in how we think about it and how we solve for the sustainability question. We also just did a very large joint venture in India, right? And at first blush, India is not necessarily a country you think of from a sustainability standpoint, and it's only since the JV is formed where I've come to learn like how advanced they are. Certainly, our partner, the Adani Group, is one of the largest solar manufacturers, as well as a developing the largest solar farm in India, right? And so we're not only just doing renewable energy credits, we're getting straight renewable energy that will largely power our facilities there. And so they're almost leapfrogging in a lot of these emerging countries, being able to leapfrog and leverage great technologies to power these data centers and achieve those aggressive kind of carbon goals that our customers have. And how do we collaborate to solve for that?
Yeah.
But I'll pass back to Rajesh on that in terms of the kind of use cases. I was happy to see him call out my alma mater in UC San Diego, which I also know has a supercomputer there and has tremendous research capabilities. And all of the biotech that they do down there requires those data sets like the petabytes that Marisa was talking about as well. So definitely a use case across these research institutions.
Yeah, for me, again, one of the beauties of using the Bloom for me is, again, I'm getting that, cost predictive, resilient, and sustainable power that you just talked about. But Marisa kind of touched on it. For me, if you ask me as a designer when I'm working with a new client and I talk about, look, I want to achieve performance, but what I tell them, I want to achieve it with the least amount of infrastructure as possible. Because when I do the least amount of infrastructure to achieve my performance and my goal, everything gets better. My design gets quicker and easier. When my design is quicker, I can build it faster with less stuff that interconnects. Therefore, my labor costs are down and it's easier to operate then, right? I need less experts that understand less interactions between systems. Unfortunately, in the cooling world, that is sometimes turned on its head because density keeps growing, and therefore we have to keep changing the cooling approach. I've kind of changed gears a bit and taking cues from some of the hyperscale guys when promoting and using a design approach using indirect evaporative cooling, where I've completely simplified the cooling approach by getting rid of all of the excess chillers and pumps and pump systems and I using a simple box that breathes through the outside of the wall of the data center. We're basically sucking air in, cooling that air, and never intermixing that with the air, and then have multiple cooling modes. But that being said, that indirect evaporative approach, Marisa, are you using any indirect, or how do you evaluate, how much do you build out before you have to think about, well, what's the next cooling mechanism that we're going to go and how we're going to adapt to that? Because it's a change. I imagine you're no different than a lot. It's a lot of chasing your tail as to how do we continue to cool these ever increasing densities.
Yeah, that's a great question. I think, when we went through the initial design of this facility, we did look at some alternative cooling methods. I think at one point, one of the designs had a Kyoto system involved. And what we found, given that there were some constraints, right? So this is an urban facility. It's narrow and tall. I mean, it's 4 stories above ground, 2 below, plus parking deck and fuel storage underneath that. I mean, it's a very compact site. And so there were some physical space limitations that kept us from doing things like that. Ultimately for us, if we can get water that's cool enough, right? And for us, that's not as cold as a typical data center. So we run right at the top of ASHRAE. Today, our cold aisle is 80 degrees, right? 78 to 80 degrees. As long as we can get that water to the right place, that's what matters. And so we are doing less and less of cooling the whole room, and we're looking to contain that cooling to just where it needs to be done.
Yeah.
So for example, in our high density hall, our research data hall, there are a couple of edge cry units, right, that provide cooling for the facility, but the vast majority of that cooling is done at the rack or even inside the rack, which allows us to get that cooling directly to where it needs to be. how that water gets cooled, right? There's various ways that happens, right? And all the typical mechanical plant stuff you talk about is in there. So far, we've spent 100 and something days, I think, since fall on bypass, right? We're getting free cooling right now.
Yeah.
When you're looking at having to keep your data hall at 80 degrees, that gives you a lot more flexibility too, in how you cool the facility. So we are looking at alternative ways to manage that heat load, because it is such a complex problem, and it is a huge expense on top of powering the equipment.
And that makes me think of something, because I see most of the innovations usage, whether it is a bloom and using it as a primary A-side power or indirect evaporative cooling or something like that. I find that the real innovation is done at that enterprise edge layer, the guy who really needs to differentiate yourself. We have such a mature data center industry in the United States that we've gotten used to doing it the approach that we know best, and then replicating over and over. And where I see in Europe and Asia right now, leading the edge as to how to build with resiliency and with sustainability in mind. And it makes me think of a quick story of a client who needed to build an edge data center in downtown London. Now think about our traditional approach to that. Think about the ground that you would need to do that. Well, they only needed about 5,000 square feet. They built vertically, I think it's 6 floors of 15 megawatt, and using the evaporative cooling on the outside of the building. And it was a little bit before we could have introduced bloom at the time, but in reality, I could have easily put a bloom right next to the building and actually have powered and cooled that building. And if you'd have told me that it was going to be possible in downtown to build 15 megawatt data center and build it quickly and sustainably, I'd have told you you're crazy. But those are the things that we're able to do today. I want to change gears a little bit. We only have a few minutes left, and I want to talk about another thing that I'm seeing going on in the world of data centers. And right now is the smaller edge, right? What we talked about there was the heavier edge, bigger data centers. And I'm starting to see, a lot of ask about micro data centers right now. And even beyond micro data centers, how about an integrated? I can tell you at PTS, one of the things that we're innovating right now is what we're calling edge data center as a service. So we want to take micro data centers, which by the way, still can be used with Bloom or in a lot of the cooling approaches we're talking about, and package it with higher performing IT, because we talked about latency and bandwidth and data gravity being a thing. Integrating the facility and the IT and putting it in a micro data center, but at the small scale. Marisa, do you have any, how are you handling those? We talked about the other day, you have certain researchers that are requiring not in the traditional data center sense. So what's your view of where the micro data center is going to play into the overall edge data center strategy?
Yeah, that's a really great question. You've had some good ones, but that's a great question, right? So because we are very decentralized, as an organization and institution, we have researchers going off and doing all sorts of crazy things, right? And I say crazy as in crazy good.
Yeah.
And this is how advances are made. You try something nobody's done before. The flip side of that is sometimes the requirements are an afterthought. And so we wind up with people who need to put 100 kilowatts of compute in their lab, right, or next to their lab. And that traditionally has been a huge challenge for us. How do we fit that in the envelope of a traditional classroom or research building, which was never designed for that? And it's honestly, we don't have a good solution. We've tried to scope things to fit that. We've tried to, there are some smaller data centers around our campus, specifically because we have this problem to meet, right? We had a piece of equipment that we needed to locate the equipment near. And so a 30 kilowatt data closet or a 100 kilowatt mini data center sprung up in a building with all the hard costs associated with building that, right, and maintaining that, has evolved because that's what it took to meet the research need. That said, if there's a better option out there, we are always looking as to how we can better solve that problem.
Yeah. Yeah, that is Philip, I see Adam's come back here, which means we only have a few minutes, but do you have any comments about that idea of the edge data center, micro data center? You're on mute.
Yeah, so I get that question a lot, right? In terms of the progression of the edge to the far edge and so forth. The there's a lot of noise around it, right? And there's a lot of hype, and I think it will come, right? And it's the same notion with 5G, right? There's a lot of hype around it. Is it a solution looking for a problem, right? And that's the other question. Again, I think it will come. We're not seeing it yet. It's a lot of proof of concepts to date, right? Some of autonomous vehicle stuff where you have the charging station integrated with a micro data center. We're doing some of that. There's various use cases, but then when you start getting into the economics versus the performance ratio, many customers kind of go back to the edge and say, hey, that's good enough, right? Now, that said, it's coming, it's coming. It's just a question of when, and I still think it's a little bit further out. For us right now, we continue to expand, and capacity wise in a lot of tier 2, our existing markets where we have edge, capacity, there's a lot of demand in having a data center in a metro. Do you need a whole mesh of 20? We're not quite there yet, right? And I'm sure there's a number of use cases out there and so forth. And a lot of people are talking about it, but I still think, that might be controversial, which is fine. I like being that. But I still think the far edge has still a little bit more to incubate before it becomes mainstream.
Yeah, as a guy who's been building enterprise edge for, at the smaller scale for a long time, I can tell you, I often want to change my name to PTS Lab Solutions, because my big multinational manufacturers have long since used co-location and are all cloud first, but they all operate these labs. And I'm just watching the labs get bigger and bigger and bigger. And where that used to be a traditional design, for me, where the micro data center is coming into play is definitely this idea that we need a certain amount of load in a space that was being purposed, office space being purposed for something else. So I can drop a rack or a container. The big trend that we're seeing is to put stuff at full of the IT and own it, operate it, and let the client consume both the facility and the IT like cloud. So we literally own it, operate it, monitor it, maintain it as a holistic, complete integrated solution, drop it on a client site and have them consume it like cloud.
And look, I'll just say one last point on that
Sure.
too. You can put the far edge micro data center out there, but it has to be connected. If it's not connected, and that's the problem, is then getting the networks there, right? And then Rajesh, I'll just to give you another segue, right, is to get it powered, right? And to be able to remotely be able to power that and then manage all those things remotely, right? And that's the glue that kind of binds all these things.
Yes.
So
so what is a fuel cell? A fuel cell is a power plant in a box. It's the utility scale power plant and the transmission line and the diesel generator backup and the UPS all in one box that is giving you reliable power cost effectively and in a sustainable manner, right? Yeah. It's that power plant in a box concept. So bring me a fiber, bring me either a hydrogen or a natural gas line, which apparently natural gas is one of the most reliable infrastructures out there, right? Much more reliable, an order of magnitude more reliable than the electric grid, right? So give me natural gas and give me fiber, and I'll build your data center, right? That's the promise, even in an urban environment that Marisa was talking about, right? You don't need the acres on acres of land to build the solar plant, but you can actually build this highly energy dense data center where you need it. And that's the promise of using fuel cells.
Yeah.
Thanks, Rajesh. Yeah, I'm actually really excited to see where that technology goes, because being able to simply get in densely populated metropolitan areas is going to offer a lot of value. So we do have a couple audience questions here. Let's jump over here. This is fair game for everyone, Pete, you included. So first question, it is directed towards Phillip. However, I'd like everyone to answer it through their own lens. So in reference to customers who are trying to achieve aggressive carbon goals, are they willing to pay extra for sustainable solutions? And how about the rest of the group after that? So Phillip, customers, and maybe it's different per customer, but largely on average, are your customers willing to pay more to be stewards of the future from a sustainability perspective?
Yeah, I think people, for us, our kind of mission vision, it centers on our customers, our people, and our planet, right? Those are our core things. And you know, you do right by all of those, then everything else takes care of itself. And I in terms of our customers, they are investing heavily, right? And they're willing to pay more because they see in the long run, it'll end up saving money, right? And saving our future and so forth. So we do see that. And at the same time, costs have dramatically plummeted in terms of renewable solutions. So the delta between, hey, the good intention and the reality has shrunk significantly. So it isn't as dramatic. So, and I think Rajesh can attest to that in terms of what they've done.
Yeah, Rajesh, go for it.
The way I would see it is, you know, absolutely right. The large data center operators are definitely setting the rules, the game, right? But then across different industries, right? There is a push to go more renewables, more sustainable, and that's the sort of the existential threat of climate change, and we all have to respond to it. But let me also add, you know, the green premium that Bill Gates and others have talked about, right? It's kind of disappearing, right? It's no longer the case that we have to pay a lot more to get cleaner power. That's not the case. That premium has kind of disappeared as well.
Sure.
Yeah,
It
that's
seems
the
like it's
point I
more
wanted
like-
to.
yeah.
That's
Yeah,
the
go
point I
for it.
wanted to make. I mean, just a decade ago, you paid as a designer. You know, my client had to bear a 30% increase in capex if they wanted that. Today, we've seen that evaporate. In fact, I would argue today that I could actually build a data center of like size for less capex today with greater greenness than I ever could a decade ago, which again lends to that why we're seeing this in Europe proliferation, because it's a far less mature data center industry and who is leveraging that today. What's interesting is we have an aging data center fleet that's going to happen. So what I see is the next evolution of data centers. How do I do bolt-on? And it's easy to do with Bloom. If I bring, you know, a fuel source into it, and can I change a data center that was tier 2 and make it resilient? And can I do it with no capex? Yes, we could bring in a fuel cell, drop Bloom at the side of the building, bring in resilient power, all for no capex because it will be paid under a PPA. And so now we've brought resiliency and sustainability and an alternate power source, converting maybe a tier 2 to a tier 3 or tier 4 operating. And that is going to revolutionize the aging fleet of data centers that are out there in the United States, in my opinion.
Thanks, Pete. Marisa, how about you and your enterprise data center, as well as your deployments in data bank and wherever else you might be? Are you willing to pay more?
So, I mean, it's baked into Georgia
If
Tech's
necessary.
strategic values, right? I mean, sustainability is not just part of what we do, it's what we help create. I mean, it's part of our mission as an institution. And so I think the answer is yes. What I've found, you know, is as we've gone through this exercise of building this facility and doing things, to speak to Pete's comment, you know, it used to cost 30% more. Right now, the things we do to support increased density and do it well turn out to be green to begin with, right? I mean, we're saving so much simply by getting the cooling right to where it's needed instead of having all this cooling floating around in space, right? Managing power and using it in better ways. It all pays for itself relatively quickly, has been my experience. So I think not only is it worth spending a little bit more upfront, right, to meet our strategic goals, right, to do what is the right thing, but in the end, it winds up being cost effective if you really do it well.
Thanks, Marisa. Yeah, and that's a great point. I mean, the point about this is with sustainability and sustainable solutions is that when you make the investment, even if it is a little bit more upfront, it pays in dividends down the line and down the road. You just have to be willing to make that initial push. We are coming at time here, so I wanted to wrap up here. Once again, another solid discussion. I'd like to thank today's distinguished speakers, our attendees viewing at home, and of course our lead sponsor, PTS Data Center Solutions. Thanks so much, Pete.
Thank you, Adam.
I'd also like to give another shout out to my team behind the scenes here at BizNet for helping us make this happen every day. We've got a lot more coming up this week, including our exploration into the South Florida market and how this region is poised to enable new opportunities in the interconnectivity and international playing field. Thanks again. We'll see you all soon.
Thanks, everyone.